We are looking at a Stellarium simulation of an annular eclipse that took place above the Boyne Valley in Ireland over 5,000 years ago in 3156 BCE on August 10th, which, by the way, this is a Julian calendar date, so in real terms it would have been more like June or July, something or other. I don't have the number in my head. I'd have to go get it calculated, but it's actually an eclipse that would take place in terms of our calendar, the Gregorian calendar, near the summer solstice, a bit after I would expect the summer solstice, but not long after. And we can see the partially eclipsed sun coming up over the horizon there on the left. And I'm just going to quickly advance the time here and bring it up. So we got this crescent sun coming up, and it's getting thinner and thinner and thinner because the moon is getting, more and more across its surface. And so now we have at 4 a.m., somewhat after sunrise, we have the thin crescent sun facing to the right, north. Now watch what happens in just a matter of a few minutes. 1 minute, 2 minutes, 3 minutes, 4 minutes. Notice how the sun is rotating around. Let's come back here. So again, 4 o'clock. 1, 2, 3, 4, 5. It's almost upside down. 6, a little past upside down. 7, 8, 9, 10, 11, 12, 13, 14. So, as we can see, within a span of just a few minutes, the sun, the thin crescent of the sun, has appeared to rotate. And I think this is important, this apparent rotation of the thin crescent sun during this and other solar eclipses, is clear appearance of rotation. And in any case, we see clearly that the sun, the crescent sun, in a matter of just a few minutes went from facing to the... Okay, let's come back a bit. And we'll just, when I increase the magnification. So here we have at 4:02 the crescent facing pretty much the opening part of it towards the right, towards the north. And 1 minute, already rotating around. 2 minutes, rotating around significantly, getting to the point of being almost upside down. 3 minutes, upside down. Even it's already passed. So within 3 minutes, this crescent goes from facing to the right, to the north, to upside down, facing south, facing towards the horizon. And then we keep going. 1 minute, 2 minutes, 3 minutes, and we can see how it's starting to face to the left. Now the moon is drawing away from the sun at this point, so the crescent is getting thicker, and it may never, because of the angle and everything, it may never actually point to the left, but sort of down and to the left. It's definitely doing that. Again, all within a matter of a few minutes. So let's go back here again. So this is about 4:06 a.m. and that's 4:03 a.m. So we're looking at about 3 or 4 minutes. It just goes from facing to the right to being upside down. Clear apparent rotation of this crescent. And that, I think, is reflected in some of the rock art of Knowth and other Irish passage tombs, this sort of rotation idea. So that's it. I want to keep this video clip short. I didn't want to go on too long. I just finished a 20-minute one. I just wanted to make that point about the apparent rotation of the crescent. Oh, did I forget to mention the solar boat business? Okay, well, we won't bother with that right now. I did mention it in the previous video clip. However, I will say this, is that on Knowth's curbstone 86, there are 4 thin crescents, very much like this. 2 are at the bottom part of the curbstone facing up. There's a line between the other crescents that are above, and they're facing down. So those crescents facing down are almost identical to this. And, you know, one can almost think of that line across the curbstone 86 as a horizon line. You know, if you think of it as a horizon line, then it's basically very, very similar to what we're seeing here. Again, I guess I got a little bit too close. Let's come change the telescope here. Yeah, so there we go. Again, so we have an upside down solar crescent not far above the horizon on August 10th of 3155 BCE. Sorry, 3155 in astronomical terms, 3156 BCE in terms of history. And again, the August 10th date, that's the Julian calendar. It's off kilter from the solar calendar. And that's why we have the Gregorian calendar now, to make things closer to the actual solar year. And so in real terms, this solar eclipse would have taken place a month or even 2 months earlier. I'm going to look into I'll find the exact date. I just don't have it right now. But it would have been closer to the summer solstice. And this is indicated here in this Stellarium simulation of the Boyne Valley. We clearly see sunrise, summer solstice right around here, a bit north of northeast here. So somewhere around here is where the summer solstice sunrise is. And whoops, what happened? Oh, I guess I just whoops, what's going on? Sorry about that. Yeah, let's come back a little bit more slowly. So here we go. You notice the rotation there very quickly because I'm speeding through. So yes, so it looks like this partial solar eclipse took place a bit after the solstice, but not a lot. You know, like I would say, judging based on this, late June, early July of 3156 BCE in terms of our solar calendar, the Gregorian calendar. And I do believe that this eclipse is recorded in the rock art of the Boyne Valley. And there was an earlier eclipse in 3315, I believe, 3316 if you're thinking in terms of the BCE. And there was also there's an even earlier one in 35 BC, 3500 BC, something or other. But there's 2 annular eclipses that fit the date for the construction of the Boyne Valley passage tombs, and that earlier one in the 36th century BCE, could have potentially had some influence in terms of earlier passage tomb art, such as Lacru's art. But certainly the 3315, I think, total solar eclipse, 3316 BCE. Sorry, not total, annular. That I think is recorded in the rock art. So we're coming back again. Look at how that rotates just in a matter of minutes. Ding, 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 ding. Yeah. So that's it. We're already longer than I was expecting to be or wanting to be on this video. But I just want to make that point. That's it for now.